Today I'm going to presenting you a vision of NEBRA Labs, which is realizing proof singularity. So first, what is proof singularity? Am I good? Okay. So first, we think Ethereum is becoming the settlement layer of our civilization. It's pretty clear. In the last 10 years, we have built this immutable ledger powered by incentives, consensus, and social layer. And that part is done, right? I do think then what are we actually going to set on Ethereum? I think proof is the ultimate form of settlement for succinctness, for validity, and for privacy, right? So here I use like a picture from Wikipedia, and any of you know what's this picture about? What is this picture? Anyone? It's actually from a Lords and Myths. So this is like YGG Dressel, the tree of the word, right? And in my view, sort of like Ethereum is a root layer, right? And there are all kind of, this is where our digital society going to form. And like why proof is ultimate form of settlement? I think from a computer scientist point of view, like my argument is complexity, right? And I think in the 5 to 10 years, Ethereum will be only having two responsibilities, right? Data availability and settle proofs. All this complexity can push to the external layers so that the base layer will be more intact. That's a vision, right? How are we getting there? So we do think we do have a lot of like incoming, and some of them are already deployed like applications powered by zero knowledge. And my thesis here is that the proofs are going to power the next 10 years of Ethereum. We have seen some of the use cases, like we have the scaling solutions, like Score, ZK Sync, Polygon Ninja, all these like ZK EVMs. We have the privacy preserving solutions, and many of them have been developed by the privacy scaling and exploration group here, the House of Events, like Somaphore, Macy, and we have like a Nocturne, Aztec, working on different kind of privacy preserving solutions. And we have, in general, oracles, for example, like Axiom, Lagrange, Succinct, and Modulus. But the problem here is, actually, in my view, this is one of the biggest problem here is the verification cost, right? And so currently, a single gross-sticking proof costs about like 250K gas. And under very moderate settings, basically, I take like the G-Way, the gas price, 20 G-Way. The running average is actually 26 in the past 6 months. And take a very moderate, like $2,000 US ETH price. But I do think it's kind of up only from here, right? You need $10. And to settle a Halo 2 KZG proof, you need like $16. And to settle a Stark proof, you need $60. And I think Vitalik used to famous said, like, do I want to pay $20 to add privacy for my transactions buying a coffee? Probably not, right? Even Vitalik cannot afford that. And I think the biggest problem here, though, right, is as the technology going better, the proving cost will go down. But if you're not doing something, the verification cost is not going to go down because Ethereum is powered by so many computers, right? So this is the first problem we're working on, right? So let me tell you our approaches. So the first question we ask ourselves is that, how can we make ZK cheaper on-chain? And the answer is using ZK. It's kind of like using magic to constructing magic. That's all this NEBRA is about. So let me introduce our first product. We call it NEBRA UPA, which stands for a Universal Proof Aggregator. So this is a NEBRA UPA, right? So the very, very high-level ideas is that we take multiple proofs, And we call it universal because these proofs can come from different circuits. For example, there may be one proof coming from a ZK EVM. There may be one proof coming from storage proof. There is maybe one proof coming from ZKML. And we can aggregate all this proof together through NEBRA UPA and constructing a single aggregated proof. And now we put the single aggregated proof on chain. By aggregating all this proof into a single proof. And now you just, for this total number of proofs, you roughly just need to pay the verification cost of the single aggregated proof. So the proof aggregator, so the proof verification costs get amortized. And so that's a very, very high level idea of NEBRA UPA. And let's get down a step deeper, right? So NEBRA is a permissionless protocol. It consists of several parts. So we have the NEBRA UPA contract, which is endpoint. People can use us. And this is deployed on Ethereum or L2s. And we have off-chain coordinators, and which coordinates provers generate a single aggregated proof. And the protocol design have this following 3 design goals. The first is that we want it to be permissionless, which means you only need to interact with our smart contract. Anyone can submit proof to us. The second is censorship resistance. So we're doing so via a very similar design compared with L2s. Basically, it's inbox and force inclusion design. And third is that we want to be progressively decentralizable, which means despite right now we're actually running on the centralized servers, we do think we will have a sequencer and prover market structure moving forward. So that's the protocol, slightly more details about protocols. The next question is, how can you use us, right? So we will be launching testnet in the coming months. But this is high level how you use us. The left-hand side is that how you settle zero-knowledge proof today on Ethereum. Basically, you deploy your own verifier contract, and you basically call this function called verify proof, and you submit a proof and also public input. And by using us, right, we kind of deploy this static contract, which is endpoint for people to use us. And now you just need to register your circuit to us using your verification key, and then just call submit proof from our contract. Then that's it, right? It's very, very simple to deploy this. And one of our engineers actually tried to modify the Tornado Cash code base to integrate Tornado Cash with us. It only took 1.5 days. And only 2 hours coding time. Others just debugging and putting things together, right? So that's how easy to use us. So then let's talk a little about performance, right? How fast can we aggregate the proof? What is the throughput? What is latency? It turns out to be a rather complicated question because we actually designed a scalable backend can scale the proof aggregation throughput if there is more demand on chain, right? For example, so we have and also we have a parallelization inside each proof batch, in the sense that we can use parallelization and the distributed computing to accelerate a single batch time. So there are 2 lines here. One is 1 compute unit per batch. One is 2x compute unit per batch. And there is a throughput latency trade-off here. And let me pick a single point in this trade-off space, right? So if we aim for 2 minutes proof aggregation latency, we can actually, so this is old number. I have to update the number here. We can roughly aggregate 250K proof per day, right? In the other word, in the Ethereum history, there are roughly about 8 million proofs, right? We need less than 2 weeks to aggregate all the proofs on Ethereum. And this is under the 32 proof per Ethereum block. And what is more exciting is that because our backend infra is scalable and event-driven, right? We can keep up with the speed of Ethereum block production. So this is like from our stress test, right? You can see like we have this like a fast backend so that we can put a single aggregated proof in a single Ethereum block, right? We can put a aggregated proof per single Ethereum block. And this is very exciting. And we're joking that we have like a proof singularity internally achieved. OK, after 2 minutes. So next, I'm talking a little bit about a proof composition here, right? Because the NEBRA proof aggregation also brings use cases of proof composition. So let's say if you want to enter a Light Club at Zuzulu at 2028, right? So possibly you need to compose this kind of proofs. First, you have a proof of humanity, prove you are human. And the second, you may want to hold a storage proof of Zupa's NFT. Last, you probably need to prove that you are not forbidden by this club, right? Like kind of like a proof of non-asshole. And you need to aggregate this single proof and verify that on-chain so that you can enter this Light Club, right? I can totally see this is happening in the coming years. And last but not least, right? I think Vitalik has, like everything we do have already been envisioned by Vitalik. He has written this like a layer 3 like blog article to envision this kind of like a proof singularity. We have a single block, a single aggregation proof per block, right? I think what maybe even Vitalik hasn't realized that this could be coming much sooner than people expected. And we do have many open questions. For example, like what's the right abstraction to give the developers? And how can we do some like L2 specific optimizations to reduce the call data? And how can we integrate it with sort of like off-chain bundlers by 4337 style the account abstraction infrastructure, and also last but least MEVs. So this is a QR code. You can scan this and follow us on the social media. And I'll come back to this. So this is the whole team. Like this is a RENIA team effort. So that's the end of my talk, and thank you very much.
Oh, we have time for like a couple questions if people are curious.
We spoke about it a bit, but what is like the ultimate cost? You spoke about it a bit, but what is like the ultimate cost you want to get down to?
So the ultimate, I think it's really about like how many proofs we are going to aggregate, right? So one aspect is that it's actually infinity in some sense, which means we should be able to like scale the proof aggregation infra to catch however demand, because we can do a like multi-stage aggregation. Like currently we're using 2-layer circuit. But if you break down the cost, right? So currently there are 2 parts. The first is on-chain cost. It's like the verifying the aggregated proof, basically we paid for Ethereum protocol. And second is off-chain worker, right? I think the ultimate cost is that we can aggregate as many proofs as possible in a single aggregated proof, and you sort of only pay the marginal cost of the actual compute, like you are getting from like generates the aggregated proof off-chain. I think that's sort of the end game here.